equation has to be a second order linear differential equation, and we are expected to know one solution, one fundamental solution, and then we will be able to find the second fundamental solution. Hopefully these examples help you to take the challenge in a midterm or final exam. So the first example is y double prime plus 4y prime plus 4y equals 0, and we know that y1 equals e to the power minus 2x is a fundamental solution. So this is a linear differential equation with constant coefficient, and we want to apply the reduction of order technique. We know one solution and we want to find the other solution. So we use the substitution. So the idea of the substitution is you take the given or known fundamental solution, multiply this with a new variable u, and replace into the equation u times e to the power minus 2x for y. To do that, you need to find y prime excuse me, y prime and y double prime. So y prime is going to be, so you differentiate it. This is a product rule. Okay, so you differentiate first function and differentiate second function. Now you differentiate y prime again. So you have two parts. In the first part, differentiate first function u double prime plus you differentiate the second function, so u prime is intact, minus 2 e to the power minus 2x. Now in the second part, you differentiate first function, which is u, so u prime 2 e to the power minus 2x plus u is the first function times differentiate second function minus 4 e to the power minus 2x. If you wish, you can simplify this. So you have two terms for e to the power, two terms for u prime. So minus 2 and minus 2, which is 4 u prime e to the power 2x, and then plus 4 e to the power negative 2x, obviously times u. Okay, so now we are going to take this quantity and substitute here. Take this quantity, replace y prime, and then take this quantity, replace y. I take this quantity and set it for y double prime plus 4 u prime e to the power minus 2x u times 2 e to the power minus 2x, and plus 4 u e to the power minus 2x. So now we are going to simplify this, and as a method of reduction of order, we expect that in this equation we will have only a second derivative term with u, so which is u prime e to the power minus 2x, and then we expect maybe there will be no u term, but there will be a first derivative term. There may not be, but there could be a first derivative term. So I think first thing we can perhaps look at here, uh, for u prime and for u prime, and yeah, so and we can see that for u prime get cancelled. So this one and this one get cancelled. If we look at the u term, this one is a 4u e to the power minus 2x. This one is a negative 2u e to the power negative 2x, but when you multiply it will be negative 16. Here you have 4, so 4 plus 4 is 8, so it's negative 8, so 4 times 2 is 8, so then that got cancelled. So this equals 0. Okay, and we can divide by e to the power minus 2x, so u double prime equals 0. So this is just an integration, so you integrate u double prime with respect to x, so you get a constant c1, so u prime equals c1. Okay, so since u prime equals c1, you integrate again to get u, and on the right hand side c1x plus a second constant of integration. Now you go back and replace u, so u is c1x plus c2 times e to the power minus 2x c1 x e to the power minus 2x plus c2 e to the power minus 2x. So e to the power minus 2x was given. Other solution, which is found, x e to the power negative 2x, and the linear combination is the general solution. Okay, so next example, t square y double prime and 6y equals 0. So in this example, we are going to assume that y is a function of t, and first derivative is a differentiation with respect to t. Second derivative is also differentiation 2 times with respect to t. And we are going to assume that we know a solution which is t square. And see, this one is a second order differential equation with variable coefficient. So substitution is going to be u times t square for y, and again we are going to substitute in this equation y double prime, y prime and y double prime. So you first calculate y prime and differentiate u times t square. U is a function of y, t square is a function of y. Sorry, u is a function of t, t square is a function of t. So you use the product rule, u prime t square plus u times derivative of second factor is 2t. So now when you calculate second derivative of y, you have two terms. So again you apply the product rule. So in the second term, 2 times u times 2u, or 2 times ut. So u prime, we're going to write u times 2t, treat it as this, plus u times 2. Okay. If you wish, you can simplify. U prime 2t, u prime 2t, so u prime times 4t plus 2u. Okay, so now you are ready to substitute t squared times y double prime, and you write u double prime t square plus u prime 4t plus 2u for y double prime, plus 2t y prime. So 2t y prime is going to be now u prime t square plus 2 ut minus 6y, y is u t square. Okay, so we're going to distribute it t square among those terms. So u double prime, we could also divide by t square, but we'll do it later. We'll see. T to the 4 u prime t cube plus 2u t square. Now in this case, you distribute 2t, 2u prime t cube plus 4u t square minus 6u t square is 0. Okay, so let's see if we can do something else. You see that u prime and u prime t cube here is 2 terms, so we can add them together, 6u prime t cube. Now 2ut square, 4ut square. So here is 2ut square, 4ut square makes 6ut square, and here is negative 6ut square. So that get cancelled, and as we expect, there will be no u term. So it's reduction of the u terms. Now I have a second order differential equation which is separable, but it is a good idea to do a second substitution. So you set u prime equals b, then u excuse me, u double prime equals b prime, then b prime to the, you could have divided by t cube, but we'll do it. So don't do it. 6b t cube equal to 0, right? Now this one is separable, so maybe first we write dv dt plus 6v t cube divided by t4. So you can divide by everything, you can divide by t4. Now you can divide by v and multiply by dt. So if you multiply by dt, you will get here dv, and divide by b, you get a dv by b. So you get 6 dt, and t square, t cube and t to the 4 get cancelled. So a nice simple equation, dv by v plus 6 dt divided by t equals 0. So you integrate it. So you get here ln of b plus 6 ln of t. So simply integrate with respect to b first term, with respect to t second term, and in the right hand side, integration of 0 is a constant. You can once we see ln, and then perhaps we can just write down ln of c1. So now on the left hand side you can rewrite it ln of v times t to the power 6. Ln of 6 ln of t is ln of t to the power 6. Multiplication goes to the power, and then addition becomes a multiplication in ln. So ln of c1. Okay. So then you have v t to the power 6 equals c1, or v equals c1 by t to the power 6. Okay, so what is b? B is u prime, so you write u prime, and maybe I just rewrite t to the power 6 as t to the power minus 6, and you integrate it. U is c1 divided by minus 5, c1 divided by minus 5, t to the power minus 5 plus a constant of integration. Okay, so you have u, and now you return back to your original substitution where you had y equals u times y1, and y1 was given t square, so y equals u times t square. So now y equals u is c1 by negative 5 t to the power minus 5 times t square, and maybe you can absorb the negative 5 to c1, that's okay. So you can rewrite c1 to be a new constant a, c1 by negative 5 and t to the power negative 5. And now since you wrote a, it looks just nice. If you rewrite b t square, so what does it tell you is that given t square a fundamental solution, then we have found t square minus 5 is another fundamental solution. So a second order differential equation, so I expect two linearly independent set, and those are the members of the set t square and t to the power minus 5, and general solution is a to the power minus 5 plus b t square. Hopefully you enjoyed and understood how to solve a second order differential equation, whether it is a constant coefficient linear equation or it is a variable coefficient linear equation. All you need to know is one of the fundamental solution, and then you apply a method of substitution and just follow naturally coming mathematical steps to end up with the final solution. If you want to get more want to watch more example, watch the next video. Thank you very much.